Now members, let us see examples in trapezium rule. The examples are very easy. All you need is a calculator. Okay, so find an approximate value of in this function, and this is alpha, this is our integral, using trapezium rule with 5 steps to 3 decimal places. Now, if they tell you to 3 decimal places, it means that now in your table you are going to give your answers to 4 or to 5 more than 3. You give to what they are telling you to. Don't give everything to 3 in the table. You give to either 4 or 5. So always if they tell you to 4 decimal places, then you give your answers in here to 5. If they tell you to 6 decimal places, you give these ones to 7. So always decimal places should be more to that of the question. So calculate the error and how we reduce that error. Now, if I'm to compare now this integral and the original function, this is my 0, this is my 1. So the a is 0, then the last integral is 1. Now the n is the number of strips. So be careful, if they give you ordinates, then that is a different case. But now they are giving us strips or sub-intervals, it's the same. Now, we need to get our height for each strip. What we do, we get the b, which is from this case, is 1 minus 0 over 5. And when you do that, we shall get 0.2. 1 divided by 5. That's the answer we get. Now, remember our formula is this. We need this, then also we need y1, y2, yn. Now, how do you know the values of x you are going to get? If you have 5 strips, it means that you are going to have 6 x values and so 6 y values. So always the x values are more by 1 to the number of strips. But if we have 5 ordinates, it means that even the x values are going to be 5. But if in case of strips and some intervals, they are always more by 1, the x values. Okay, so how do we know? Now we do that the first, remember we are integrating from a up to b. So from so our x value, the first x value is always this lower limit. So it's going to be 0. Then from this, now to know the next x value, we add 0.5 until when we reach our last value. So here we add 0.5 to get 0.2, 0.4, 0.6, 0.8, then a 1. So you see there 1, 2, 3, 4, 5, 6. Then the strips were n. So these ones are always more by 1. If they give you strips, if they give you ordinates, then it's the same number. So meaning if we have 6 x values, it means that even the y values are going to be 6. But we say this the first and the last are always going to be in this table. Now we draw a table of 3 columns. The first column we put x values. Now the next column we put the first value of y naught, then the last value of n. So our n, they are going to be 6. So this one is going to be y6. Or some people put here y. Okay, now the next, now we are going to, now the remaining, remember this is the first, this is the last. So here we are going to have now y1, y2, y3, comma, and y4. Okay, so what are we, so that's what we have basically. y4, then our y, those are the strips we have. 1, 2, 3, 4, 5, 6. So this is y5, not because the n in our case is okay. So after getting these values now, we now get the values of these ones. Now, what the question is, how do we get y0, y5, and these ones? Now, always the function they give us in that equation is always our y. So to get y0, we substitute the value when x is not here. So this value is what we put here, so that we can get the answer. And I'm going to show you how to do that. What we do, the function we have is 1 over 1 plus x. So let me show you how we do that. So what you do, you get your calculator. You start that value is 1, so you say 1. Now we are dividing with 1, then you see it's a plus, then plus. Now here we are going to always put the x values. So the first x values is 0, then you cross. When you put there equals, you get 1. So it means that now our y naught is 1. Then here we have y naught and y5. So now we come and put in also the y5. The y5 is the last one which we are going to put here. So the value we put here, you press now. So that our last is going to be a 1. The yn corresponding to the last value of x. So you put there 1, then you press equals. So it's 0.5. But we said you give to 4 decimal places as we saw there. Okay. This is 0 now. 0.5, 0, 0, 0. We give to 4. Why? Because our question said you give to 3. So if we are the question wants 3, for us in these tables we give to more decimal places. That's why I'm giving to 4. So then we are going to come for these last values here. Now this is now my y1. Y not y1. So what I do? The same thing, 1 divided by 1 plus. Now the next value you put like this. Now you say 0.2. It's the next x value. Here we are putting the value of x because it's 1 over 1 plus x. So the value of x, they are what we put. It's what I'm putting in there. Then you press equals. So then you give this answer to 4 decimal places. So it means that now this corresponding value of, the corresponding value of x is going to give me 0.833. Then this one you change. Now the x is 4. So it's going to be 0.7 to 4 decimal places. 143. Then the next you change to 6, 0.6 now. It's going to be 0.6250. Then the next is going to be 8, 0.5556. Then the last one, so this is y1, y2, y3, y4. Then this is my y5 and this is my y0. So after, all we need now to sum all these ones here. So you get your ruler and then you cross our table. So cross that table. Then you put the sum of here. So here now, when you sum this, we get, when you sum y naught plus the whole of that, you get 1.5000. This is okay. Then this one, when you sum, when you get your calculator, and then you sum all those values. So here when I sum, I get 2.7282. So now that's the answer I'm having. So now, after we substitute to our formula, now here, our formula is going to be, our area is going to be approximately a half h into, now y naught plus my yn is y5, then plus 2 into y1, y2, y3, y4. That's where they are ending. Then it's a matter of substituting. So now my a will be a half times 0.2, my h, into, now when we sum these two, it got 1.5, then plus 2 into the sum of all these ones, 5, 2, 8, 2. Then close. Then our value here is going to be an approximate. What you do, you first get this, then multiply it by 2. Then after the answer, you add that, so plus 1.5. Then the answer, you multiply times 0.2. Then the answer, you divide by 2. So here the answer I'm getting is 0.695564. But our question said it's 3 decimal places. So now my answer will approximately be 0.69. Now to 3, 6. Now these are 3 decimal places. So that will be your answer. I repeat, if they ask you to 3, you give your answer as to 4. If they ask you to 4, give you these values to 5. If they ask you to 6, you give them 7. These decimal places should be always more than what the question wants. Then calculate the error made. To calculate the error made, you know that our error in part B, always our error is equal to modulus exact minus the approximate value. So now we come for our exact. Our exact is now when we interpret this integral. So now our exact value will be now integral from 0 to 1 over 1 plus x dx. And so that when you integrate this, you get natural log of 1 plus x from 0 to 1. This will be natural log of 2, then minus natural log of 1 after putting in a 1. And that will give you natural log of 2 will be 0.693. We also give it 3 decimal places. Now after that, I come and I calculate my error. So the error will be modulus the exact. Now this is the exact value, which is going to be now 0.693 minus now the approximate value, which is 0.696. So my error will be going to be 0.003. This is the error made, but it's giving a negative, but we are getting absolute value. That's why I'm having this. Then part C, how can we reduce on that error? Reduce on that error, you just said we should increase the number of sub-intervals or strips. Sub-intervals or strips. So you have everything there, and so that's how we can get question. We are going to start an example. See you.